all of a sudden giving AI a body is becoming economically viable at scale.
Are we ready for a world in which our thermostats negotiate with the power grid and our beach towels have a chip, a sensor, maybe a radio? Hello and welcome to TechFirst. My name is John Koetsier. We spent the last couple decades embedding intelligence into the digital world. What if it wasn't limited to that? What if the next big shift is putting intelligence into everything, everywhere? Machines, devices, buildings, products, tables, houses, all this stuff. So that they not only sense, but they can reason, they can act, and they can learn. It's kind of IoT on steroids. To chat, we have Mat Gilbert. He's Director of AI and Data at Synapse. Hello, Matt. We're talking about a world, a future that's coming faster than most of us can anticipate. And we see a lot of stuff going on, humanoid robots, all this stuff. Welcome to the show.
Absolutely. Thank you. It's great to be here.
We're going to talk about physical AI, where it is, where it's going, where we see the biggest opportunities, robots, humanoids, factories, everything. Let's start here. We see obviously the leading edge of the wedge in smart objects or things in our kitchen or maybe our home or office or factory. How do we make physical AI kind of cheap, robust, and long lasting rather than expensive, kind of isolated and fragile?
Yeah, I think that's a great question. I think one of the things that's really driving the deployment of physical AI is the fact that hardware costs are just coming down. So outside of the physical AI space and within it, hardware costs, they've just dropped. Things like lidar sensors, which we often use as, say, the eyes of autonomous systems and robotics, they've dropped from kind of $75,000 a decade ago to under $1,000 now for essentially the same sensor. You think about mobile autonomous systems, you think about power. Things like battery packs are down about 85% in cost over the last decade. So all of a sudden, giving AI a body is becoming economically viable at scale.
What was the figure? What were the figures on that lidar again? 200,000 to what?
So 75,000 down to sub 1,000.
Okay. So a factor of 75 times cheaper. That's almost a 2,000% or 1,400% reduction that we've heard about from some political leaders, but we won't go there. Where are we in this era of physical AI? I mean, is it the first inning? Is it the second, third? Have we even started the game yet?
Yeah, I think we're seeing active deployments today that are showing real ROI. Like manufacturing and logistics is a real kind of they've been very much the tip of the spear in terms of live deployments that have moved beyond pilot to that scale. So you think about things like Amazon Robotics. Amazon now claim they have over a million robots deployed across their facilities. That's driving a 25% boost in efficiency. And that's happening today. You've got companies like FedEx with very similar types of deployments. So we're really seeing the first large-scale deployments of physical AI that are demonstrating good ROI today. It's already here. It's not science fiction. It's only going to accelerate, in my view, as we go forward. It's a really exciting time, I think, to be looking at the space, and it's a really good time to be thinking about how it's going to change pretty much every aspect of the world we operate in over the next kind of 5 to 10 years.
I was just chatting with a director at Amazon this morning, actually, and he said that they've seen a 25% efficiency increase due to the automation, robotics, and software that they've implemented around that. That's a big part of it, right? You've got the robots going all over the place in the warehouse or the logistics center. But you've got to have smart software that tells them where to go, what to do, and also to put things in a logical sequence so that you can pick common orders quickly with different things. So there's big components of this where there's physical AI and there's actually the old school digital AI, some centralized, some localized on the edge, the things like that. Where are you seeing most of this? I mean, you gave some examples and it was kind of in the world of logistics and warehousing and stuff like that. Where are you seeing most physical AI right now? Where do you see the most opportunity in the future?
That's it. So I think kind of outside of logistics and manufacturing, I think the classic kind of robotics automation jobs, so these tasks that are dull, dirty, or dangerous, the classic 3Ds of this space. So there's some really good examples in kind of maintenance applications. You think about a company like Gecko Robotics. So they have AI-powered robots that can climb the walls of industrial scale boilers and pipelines and climb into areas that are essentially really unsafe for humans. And the data they gather then feeds back into their technicians' insights. So when they're undertaking tasks like predictive maintenance or preventing failures, they have all this additional data. So again, it's a kind of a different, but still very industrial focused application. Over Ford, they're deploying robotic exoskeletons, which help to reduce the physical strain and injury for their workers that are doing very repetitive physical tasks. It's across a broad range of industries, I think, and we're seeing a ton of different types of applications as well. So you've got the classic self-driving car, but that space is expanding to autonomous construction machinery, so large, heavy industrial equipment, right through to these very tiny kind of gecko-sized robots that run around these borders. So it's touching, I think, a lot of different industries, and we're seeing a lot of startup activity in a ton of different verticals, which is very exciting.
It's super interesting. I hit on the software layer earlier, right? And that's pretty critical, right? Because you can have all this smart stuff all over the place, but if it's not connecting, not talking to each other, it's not working together, not organized, you end up with a mess, don't you?
Absolutely. Yeah. And I think this is the real inflection point. We've got these, not only the hardware has come down in cost. I mean, fundamentally the way the hardware operates hasn't evolved a huge amount. All of the kind of key advances are in the software layer. So you're seeing this real collapse of both the hardware and software engineering into this smart physical AI system. And I think one of the other really interesting things that enables is this kind of closed loop. So if we look at something like Tesla as an example, and like a Tesla, when you buy a Tesla, it's not the finished object. The features you have on day one aren't the features that you're going to have on day 3, on day 5, a year down the line. It's essentially kind of an evolving software platform on wheels. You've got hard sensors collecting real world data. That data is then used to train and improve the AI. The AI is deployed back across the entire fleet of Teslas via over-the-air updates. And you've got this really dynamic recurring revenue type service relationship, which is new to the car industry. Beyond kind of dealer relationships, this is a new service model. And I think we're starting to see that with robots as a service as well. So again, you've got the software and the hardware working together, potentially being maintained and updated by a third party, but deployed and solving your problems in your organization.
Yeah, yeah. I want to talk a little bit about where the intelligence lives. And we're going to talk about humanoid robots in a bit, but I was talking to a couple different manufacturers of them, and they've got a layered approach, right? You need to have some local intelligence because you want quick response times, right? And so you might be running a small scale LLM to understand a few things, or some other AI engines to do that. Some are building in quite sophisticated ones, because if a robot has to send a message up to ChatGPT or OpenAI every time it needs to make a decision about where to go or what to say or what to do when there's somebody in its space or something like that, I mean, you could have these 5-second lapses before you actually do something, right? How do you see that evolving from like cloud AI and edge AI?
Absolutely. Yeah, I think the evolution will mirror kind of the Internet of Things. I think this is a good example. If we look kind of a decade ago, there was this goal that we're going to connect everything to the cloud and it will become smart, it will become intelligent. And but the reality is that didn't really happen. We just ended up with data that now existed in the cloud and no real kind of smart device intelligence around it.
Yes.
I think now we're connecting the sensors, the data up to AI models, and we're starting to see some of that intelligence and that reasoning happen in the cloud. But similarly to kind of the IoT space, where the processing initially happened in the cloud, and then as hardware came down in cost and increased in capabilities, more of that processing was pushed to the edge. Which has upsides. If you're an organization trying to reduce your cloud costs, the more you can run on hardware that is at your consumer site, it's gonna drive your hardware costs down. Not only is the technical driver of, if I need a very quick real-time processing and reaction, I'm probably going to put that on the edge. I'm also maybe deploying sensing and processing on the device, maybe at the edge, so on premise, so not up in the cloud, but also kind of connected locally. And then there's a cloud piece as well for those longer latency tasks. So you've got this very hybrid model. It's different, I think, for every application. Every application has very different needs and requirements, and that's what drives that architecture. But I think we think today that, yes, kind of everything is cloud-based, particularly kind of the chat GPTs of the world. More and more, as you call out, with small language models, they're capable, they run on the edge, and you can think of these things as more of a pipeline. So there's actually an edge classifier happening on the edge, and that's feeding a small language model, and then maybe those insights are going up into the cloud, and you're seeing those higher level, longer running decisions happening up in the cloud.
And some of those SLMs are getting amazingly good, right? They're pre-trained, they're focused on a certain narrow set of activities, and they're really, really amazing. That's incredible. Some others that I've talked about, and we'll get into the conversation of humanoid robots now, they've actually taken the human model where we actually have our nervous system, which helps us understand the world and react to it and all that stuff, extends out to our extremities, right? We have some processing very close to where you actually get sensory data. And then you have more processing in, let's say, your spinal column, and then even more in that big bulky thing you got to carry around on top of your neck, right? And so they've adopted sort of similar models to that. So pretty interesting. It's fascinating how the future is going to work on all this stuff. Let's talk about humanoids right now. There's a huge amount of investment here. There's a lot of innovation here. There's also a lot of people who are super skeptical and saying, like, hands are impossible. You're not going to get them. You can do grippers. We've got 1,000 varieties of those, but it's really, really hard. You don't really need legs. If you're in the warehouse, it's all concrete and flat and level. But we have a lot of investment and a lot of innovation going. How do you see this space evolving?
Yeah, so I think humanoids are a really interesting example. If we believe the kind of the current premise, 2026 will be the year of the humanoids. I think there's a really interesting commercial race going on now. So you've got this very high stakes race towards the first commercially viable humanoid robot, and I think there's a few key players, and they're making different strategic bets on what the biggest bottleneck to scaling physical AI technology is in a humanoid form. And so if you look at companies like Boston Dynamics, so they've been around for multiple decades at this point. I would say they've really mastered dynamic motion and balance. That they're all about agility.
But they just kind of recently went from systems that were kind of old school to actual electrical actuators, right? So they're kind of new in some of those areas.
For sure, and I mean their new Atlas robot, I think it's a marvel of engineering, for want of a better
I
phrase.
agree.
It's a really impressive piece of equipment. But the bet that they've made fundamentally is agility, and mastering that complex physical agility is the hardest problem and the biggest bottleneck to scaling. You compare that to somebody like Figure AI, so they're very, very, very focused on designing a robot that's suitable for mass production from day one. So they've partnership with OpenAI for the brains to use kind of a human nervous system as a model. And they have a partnership with BMW, where they're deploying into factories for a real day one factory use case.
Yes.
And their strategy is all about this scaling and getting to practical application as quickly as you can. And then you can look at a company like Tesla, again taking a different approach. So they're making more of this AI first. So they're leveraging the huge amount of data from their self-driving cars and their AI stack, and they're trying to solve essentially general intelligence first. And then from there, their bet is you can deploy that into their Optimus robot, which has already been designed for work in their own factories.
Yeah.
So I think this race for the humanoid, the winner is going to be the company that made the right bet on what that bottleneck is, and it'll be really interesting to see, I think, next year.
And there's so many bets out there, right? I mean, on the Tesla side, it's really hard to progress if you fire your team every 6 months or something like that and restart. You've got all that data, great, but and you've got Agility Robotics. They've got Digit. It was the first robot to get a paying job in a factory, right? But I think, as you kind of alluded to, it might be fired if it wasn't a test project. It has a robot that's doing a paid gig right now as well, but it's so early days. Apptronic is super interesting in the space because they're super practical. They're not looking to boil the ocean. They're looking to what works, what do I do right now, what can I get paid for right now? And they come from a long history of building industrial robots as well. So as they come to humanoids, they bring that sensibility with them. It's super interesting. Let's give it a timeline. In your opinion, your mind, when do you think we'll have a robot that's living in our home with us and maybe vacuuming a little bit? I'm not talking about a Roomba. I know that's a robot too. And baking some cakes and maybe, I don't know, even a little childcare from now on.
Yeah, I think in terms of environments, when we think about environments, I often think that the home environment it's the biggest challenge. It's almost a last frontier for autonomous robotics. They're very unstructured environments. If you look at my home, I have two small kids. That environment is very dynamic. It changes all the time.
Everywhere.
Absolutely, for sure. There's always something to trip over or something new. So getting kind of a full autonomous humanoid type robot into that setting is a challenge. You looked at kind of call out Roomba, looking at where robot vacuum cleaners were a decade ago. Their algorithm was they run around, they bounced off all your baseboards, and eventually maybe they'd have covered most of the space that they were meant to clean. Compare that to where they are today. They're doing SLAM navigation, they're mapping out your specific home, they understand obstacle avoidance, they're doing object detection, and they're a lot smarter than they were. And I think you can apply that forwards. There's a famous a test, the coffee test, which I think is a really interesting one for robots today. We know we'll have solved kind of general humanoid robotics is when you can take a humanoid robot and it can walk into any American home and make a cup of coffee, which I think is a really interesting test because every human, pretty much, you could figure out in somebody else's home how to make that cup of coffee.
Yeah.
For a robot to do that in a bunch of different environments is a big challenge. So I think where we are in some of home environments, I think that's further off. That feels like in that 5 to 10 year range, kind of at the earliest for consumer environments.
What was that? Did you say 10 year?
I think we're in that kind of 5 to 10 year range before we're really there. There are applications for kind of specific. I like the kind of like there's like a home chef, a professional chef setup you can buy on the market now. Right now, the price point is around $250,000. So it's not a consumer device right now, but the capability is there. So as we know technology, we'll see that price come down.
That's a really good point. We got the bits and pieces, right? We have the little robot that does clean your home. It's a Roomba or the equivalent, right? There's many brands out there right now. We have the chef robot, which is stationary, and you got to put stuff where it can get it, right? And it can make you some food, and that's great. And we have other robots that are doing other stuff, and the whole package isn't quite there. I like that test that you mentioned. We do see some interesting things from Figure, which is showing robots that are putting stuff away that they haven't seen before, groceries and other stuff like that. So they have some sense of what this is. They're using some intelligence there. But yeah, there's a ways to go there. So what are some other places where we should look at that physical AI is making some huge strides right now?
Yeah, I think kind of as we call out, manufacturing and industrial settings logistics settings are the biggest place for commercial deployments. But you're looking at like agtech, we're seeing physical AI applications, so people like carbon robotics, with their laser radar. They're on their Gen 2 now, and it's only doing good things from both a technology perspective and an environmental perspective, which is excellent. We're seeing some interesting applications in the healthcare space as well. I think this one was a bit of a surprise to me. So healthcare to me feels a little bit like we shouldn't have kind of autonomous systems. I quite like a human to be in the loop in the healthcare space. But what we are seeing is applications in elder care. There's this robots that are providing company for people in elder care settings, facilitating video calls with family, providing medication reminders, those types of tasks. So easing the burden on human carers and amplifying that human touch as well. And in hospital settings as well, we're now seeing physical AI deployments where we have robots that are navigating the hospital corridors, delivering medication and mass supplies. So with healthcare, we've got I think it's a really exciting and high impact frontier, and we're looking at really amplifying the human touch of caregivers in the healthcare space. The robot that's navigating corridors to deliver supplies, lab samples, and medication. There's a company called Diligent Robotics that have, I think they're called Moxie is the robot from there. And you're looking at really automating these time-consuming non-clinical tasks, which means you're freeing up the healthcare staff to do what they do best, which is direct patient care.
And we've all heard the horror stories, like in old age homes or something like that, where there's one or two or three carers for 50 or 75 or 100 people, and elderly people are just left in appalling conditions, either because there's a lot of different reasons there, but it's difficult to get people to do this stuff. My mother struggles with dementia at 91, and that's there's just needs that you can have a very patient system that can be more patient than humans, which is super, super helpful. I want to hit adaptability. We kind of mentioned that a little bit because you went into like this test of a humanoid robot or general intelligence. We know if solved, it can go into any home, make some coffee, and there we go, right? This kind of adaptability, machines doing what they weren't programmed for. I mean, we see that in generative AI. We see that in LLMs to a degree and stuff like that. How do you architect for that in a safe way?
I think, you kind of hit on a key point there, which is safety, unwinding before we get there. I think looking at these generalist robot policies, these kind of foundation models for robotics, you've got groups from NVIDIA, high zero physical intelligence. They're really trying to build, and they are building this general purpose brain for robots. So allowing them to do exactly as you described, learn skills and handle situations that they weren't explicitly programmed for. One of the kind of key feeders for the ability, well, one of the key enablers for foundation models is the current maturity of the simulation and digital twin type tools that we have. So you can now train a robot for millions and millions of cycles in a very physically accurate world before it ever hits the factory floor, it hits a physical environment. And by doing that, you're building these foundation models a lot rapidly and a lot more safely than kind of alternative approaches that have been used historically. I think when you're thinking about safety, physical AI, I think has this real critical distinction as compared to digital AI. Digital AI fundamentally operates in a world of reversible transactions, for another way of putting it. If ChatGPT hallucinates and gives you a wrong answer, it's an informational error. It's something you can correct, ideally.
Yes, if you're paying attention.
Absolutely. And these systems are grounding themselves. They're improving all the time, but it's any kind of digital error it lives in the digital world. For a physical world, actions often aren't reversible, they're irreversible. So that same hallucination that gives you an incorrect fact, if that's in a robotic arm controller, then it's not just a wrong sentence, it's potentially a catastrophic physical movement.
Let me unbreak that arm for you.
Absolutely, yes. That's not something anybody ever wants to be saying in a physical working environment, for sure.
Yeah.
So I think you absolutely have to have safety designed in. It's the foundational design principle of any physical AI system. We talked a little bit earlier about hybrid systems, and I think this is where you can really start to build out these multiple layers of safety. So when your AI model is suggesting your robot makes a certain action, kind of how many filtering layers does that go through before the actual physical action? And the more filtering layers you can have, the safer you can build your system. And again, these systems need to learn over time. So for autonomous vehicles, Waymo is a great example. They trained on millions of hours of recorded driving data in a simulation before they hit the road. And that, I think, applies right across any physical AI application. So you really do need to think about this kind of, what are the consequences of something going wrong? And they are exponentially larger in the physical world. I think extending beyond just kind of the AI inference, thinking about just cybersecurity and cyber attacks as well. Digital cyber attacks obviously devastating and can be bad from a data breach perspective, but it's not just a data breach if it's a physical AI system. It's a potentially malicious actor taking control of really heavy machinery. And again, you need to be thinking as you start deploying these physical AI systems into environments where perhaps cybersecurity hasn't been a concern. You suddenly have this new edge that you need to secure.
Yeah, that's a tough one, right? I mean, we've seen the exploits by people who went in via some smart software in like an aquarium. That's the famous example, right? And we've all seen the movie I, Robot as well, right? So I was going to be a devil's advocate about, digital AI can make mistakes and say, oh, by the way, your bank just erased your balance. But yeah, there are some safety systems around that. So I 100% agree with that. It is challenging as we lean into LLMs for robotics, is that LLMs are probabilistic. They're not deterministic. That's why they get it wrong sometimes. That's why they hallucinate sometimes, right? And you want the power that you can get from an LLM, but you do need some deterministic barriers on what smart systems, physical AI systems can do, because we don't want broken arms or broken noses or just collisions or other things like that.
Absolutely, yeah. And I think you can, again, thinking about kind of layers of safety. I'm thinking through some recent environments I've been in where you have an autonomous system, and if it detects any motion within 10 feet or 10 feet or 30 feet of it, it just stops. It just shuts down and it won't do anything until it's happy that it's clear. And that's not the higher layer kind of AI model reasoning about that. That's a very low level physical command. You just can't move the system if it's detecting people around it. So that's kind of one layer, and then you just need to keep building those up. And then I think as you've got a system that's as safe as you can probably make it, and then you can start thinking about how do we improve the productivity. So a system that shuts down whenever there's anybody too close to it, is great for safety, not necessarily great for productivity. So how do we design the system so that we still got the same level of safety, but we also got that level of productivity as well? And I think that's an interesting engineering challenge, and it's one that I think the industry is working on all the time. And this concept of working alongside robotics and automated systems, kind of this human robot teaming, human AI teaming, I think is almost the next frontier of physical AI. How do we design a system that is fun to operate around, safe to operate around, productive to operate around, but also communicates its intent to the human? So you have this bidirectional communication.
Yeah, interesting.
So yeah, I think if you think about kind of humans and robots as teammates, you've got a good teammate. They're predictable, they're trustworthy, and they communicate intent really effectively. But how do you design a system that builds trust when trust is very easily broken, as you say, by something unpredictable? So if you have behavior, how do you trust this system? How do you solve the problem of these very messy, unpredictable environments without needing to constantly reprogram? And that's where these foundation models are really solving for those types of use cases.
Yeah, that makes sense. Maybe we'll close here. 2026 is just around the corner. What do you see as kind of the next steps, next evolution that we might see come out to the market next year?
Yeah, I'm excited to see. I think all of the applications, I think as we mentioned, I think consumer applications are a little bit further away, but consumer facing applications, I think, are just around the corner. So you think about physical AI, I think the first wave of deployments they're almost kind of out of view of most of us. They're behind the walls of distribution centers and in manufacturing settings. But the next wave, I think we're seeing advances in like service robotics, so deployments in airports and restaurants for the robotics that will come and serve you drinks or bring your food to you. Those types of systems, I think we'll see. I think they're coming. They're there already in some places. I remember being served drinks by a robotic waiter not so long ago, and was overly impressed and spent far too long of the meal trying to figure out how he didn't spill the drinks as it was driving. It was very impressive. But we're going to see those more kind of B2B applications and then business to consumer applications. I think consumer facing a little bit further down the line, but and
this is we're going to see this more and more in our environments, of course, right? Like I just did an interview with Starship, and they are the largest home delivery bot service. So they'll take groceries from a local store, deliver it to your house. It's a 6-wheeled robot that travels on the roads, crosses roads, travels on sidewalks. It'll go up your sidewalk and near to your steps so you can get it and do meals that way. Uber Eats just brought out Spot, I believe they call their robot, which is essentially the same thing. Keep your food warm, deliver it. And we're seeing more and more in terms of drones as well. And that's actually deploying real live. That's been multiple years that it's been going in some places in Europe, and it's been a couple of years at least in some places in the United States as well. So we're going to see those things globally. So it's going to be an interesting world, because physical AI has meant for a lot of us, if we're not in a huge logistics center, it's meant some, I don't know, smart cup that keeps my coffee warm or something like that, right? Or maybe it's an Apple Watch or something along those lines. We're going to be seeing this more and more in our built environments, and that's going to be a phase shift for us.
Absolutely. Yeah, I think not only in those kind of last mile delivery applications, you're going to see it in entertainment venues is going to be a big one. So you think about kind of smart spaces and connected spaces, kind of what are the new experiences that having a smart, adaptive environment that's aware of you as an individual and you as a part of a crowd, what does that unlock? So I think that's another place that I think in the very near future, we're going to see more physically aware systems, and they'll only progress over time.
Super interesting that you brought that up. I was just in a museum in Las Vegas, and there was a place in there where you could draw something and it would immediately animate it and show it huge on the wall, just massive. It was quite impressive, actually. Anyways, super interesting conversation. Thank you so much for your time, Matt.
Absolutely. Thanks for having me.